Hello, welcome to the video about H-Hope current meter. H-Hope is a European project on hidden hydropower. The device enables us to measure velocity in open channels, open streams. It is composed of two parts, the vane and the electronic box. Both have been designed with a do-it-yourself principle so that you can perform the manufacture at home.
Now we will explain how to assemble H-Hope current meter. The most important part of the H-Hope current meter is the vane. First we will assemble vane holder. Here we can see the parts needed for assembling the vane holder. If we start from the left side, we can see the vane holder. Vane holder is made from several small components. We have a fixing screw and a nut. The nut must be inserted inside the vane holder. Now we can insert the fixing screw into a nut. Next component is a slider. This is a slider. The slider is used to fix the vane to a stick or a pole. Slider should be inserted into a vane holder. Like that. The next component is a Hall sensor. Hall sensor must be installed into opening into the vane holder here. So this Hall sensor is used for measuring the rotation speed of the vane. Hall sensor has three pins. The first pin is the power pin, the middle pin is the ground pin, and the last pin is the signal pin. We need to solder a wire to each pin of the Hall sensor. First, the wire must be prepared. We remove approximately 2 centimeters of insulation and strip each wire. We remove the insulation. And then we also need to strip the remaining 2 wires. We can apply some solder to the pins of Hall sensor and wire. We also apply some solder to the wire. Then we need to solder each wire to a separate pin on a Hall sensor. We remove the insulation. We first solder the brown wire which goes to the first pin. Then we solder the shield wire which goes to the middle pin. We need to solder the white wire which goes to the last pin. After we finish with the soldering the wires to the Hall sensor, we need to install this Hall sensor into the opening in the vane holder. Here. We put cable through this hole. And install Hall sensor into this seat. Before the installation, we must check that the wires are not touching each other. We will apply epoxy glue to glue this Hall sensor in place. Today we will use 5-minute epoxy. The epoxy glue will also protect this Hall sensor from the moisture. We mix the epoxy glue and apply it to the Hall sensor. We will now proceed with the assembly of the vane. For vane assembly we will need 2 bearings, vane, a small magnet and a vane cap. First we will insert the bearing in the back side of the vane. After that we will insert the second bearing in the front side of the vane. We can use tools to help with the installation. We will glue small magnet in the hole in the back side of the vane. We insert the magnet in the hole. Okay. So this magnet is then detected by the Hall sensor to calculate the revolution speed of the vane. We can use quick glue to glue this magnet in place. When the glue on the magnet is dry, we can insert the vane into the vane holder. The side with the magnet must be attached first. We check proper installation of the vane by confirming that the fixing pin on the shaft is holding the front bearing. We finish the assembly of the vane by securing the vane cap. So here you can see the finished vane assembly. The second part of the H-hope current meter is an electronic box. Here we can see the parts that we need for assembly of the H-hope current meter electronic box. The heart of the H-hope current meter is the Arduino Uno. Arduino Uno is a microcontroller and it's responsible for calculating the water velocity. We also have 3D printed enclosure, a top and a bottom part. Here we have an LCD display, on-off switch for powering the device, 9-volt battery with the battery holder, like pins, screws and wires. First we need to insert a Hall sensor cable from the vane. We insert the Hall sensor cable in the hole on the bottom part of the enclosure. We need to install a battery holder. We install a battery holder into the bottom part of the enclosure. Here you can see opening. Through that opening we install a battery wires. Next we install on-off switch. We will install on-off switch through an opening on the upper part of the box. We secure the switch with the nut. Next we will install LCD screen. The LCD screen will be also installed on the top side of the box. We use 4 small screws to secure the LCD screen in place. Now, when we have all the components fixed in the box, we can solder end connectors to the wires. On the Hall sensor cable, we first remove around 5 centimeters of cable insulation. Then we need to strip each wire. We will solder X-H connectors to the end of each wire. We will apply some solder to the connector and cable before the soldering. Okay, the first wire, the second one, and at the end the shield wire. We also need to solder the a red wire from the battery holder to the one pin of the battery switch. On the negative side, on the black negative wire from the battery holder, we need to solder the connector. The connector is the same as on the wires from the Hall sensor. We also need to solder another wire with the end connector to the other pin of the on-off switch. As you can see, this wire has already connector on the other side. So with that, we are finished soldering all the wires. Then we need to install Arduino Uno microcontroller on a pre-printed pins in the bottom side of the electronics. So here you can see the pre-printed pins on which we will install Arduino microcontroller. Like that. Then we need to connect the Hall sensor cable to the Arduino microcontroller. Hall sensor has three wires: positive, which is brown; white, which is signal; shield, which is ground. So this positive brown wire goes to the voltage supply pin. On Arduino Uno there is an eCSP port here, which has power supply pin, and this pin is the ground pin. So the brown wire goes to this pin, and the shield pin or ground pin goes to this pin. We will attach these wires with connectors to the pins to the connector. The brown wire goes into the third pin opening, and the shield pin or ground pin goes to the first pin. Okay. Then we have another wire, which is the signal wire, and this wire goes to the pin 2 on the Arduino. We will now connect the Hall sensor to the Arduino. Like that. And the signal wire goes to the pin 2. The schematic for wiring the Hall sensor to the Arduino is also available on the GitHub HOPE repository. Next, we connect the wires from the battery holder. Black wire goes to Arduino ground pin. Arduino has two ground pins available here. Okay, so the black wire from the battery holder goes to Arduino ground pin. The red wire that goes through the switch, we connect that wire to the Arduino in pin. So at the end, we need to connect the LCD screen. We do that by 4 wires and 2 connectors. We insert the 4 wires into an opening in the connector. We will insert the pin with 4 wires to the LCD screen. This LCD uses I2C protocol to communicate with the Arduino Uno. We need 4 wires to connect the LCD screen to the Arduino. Here you can see we have 4 wires. First one is system clock. This is this wire, which goes to the Arduino pin with the same name. You see here system clock. This is the first pin. System clock to system clock. We will connect this connector into these 4 pins. The first line goes to the first opening. The second pin is called system clock. That will also go to the same name in the Arduino system clock, the second pin. We also have additional 2 pins for powering the LCD screen. First one is the VCC, which means power supply. That pin goes to the 5-volt pin on the Arduino Uno, which is this third one. And the last wire, which is the ground pin, also goes to the ground pin on the Arduino Uno. We then connect the 4-bar connector to the Arduino Uno. System clock pin is the first pin, goes to the first pin, which is also system clock. The second pin is system data, goes to the second pin, which is the system data. The third pin is the bar voltage pin, which goes to the 5-volt pin. And the last pin is ground pin, which goes to the ground pin on Arduino. So now we need to program the Arduino Uno with the source code. Instructions on how to program the Arduino Uno are available on the HighHope GitHub page. Now, after we have all the wires connected to the Arduino, we can assemble the top and the bottom part of the electronic enclosure. We will use 3 M4 screws to do that. And be careful not to over tight the screws. And use 3 M4 screws to close the box. So at the end we need to connect the 9-volt battery to the battery holder and close the holder with the battery holder cap. We can now power on the HHope current meter and test the operation on the field.